Now, today's lesson is going to be about standard input and output. So that's producing output to the user and reading in input from the user. And at the end of this, we're going to write a simple guessing game program to sort of sum up everything we've learned thus far. So let's just go ahead and get started. To do this, you're going to need, or all of the input and output functions are contained within the IOStream header. So make sure you have that included and you're using the standard namespace, which you should already be doing if this is just a new project. If not, just go ahead and type those in. Now, we're going to start with output because it uses a function which you should all be very familiar with. This is that magic function, which you all just sort of had to accept. So this is cout, and the way cout works is by writing to the stream, and the stream is what's put onto the terminal. Now the stream works by using these arrows here called stream operators, and the arrows in which they point is very important. For cout, the arrows must point to the output. They have to go into the stream. Now, these stream operators also serve to concatenate data together. They are able to take multiple data types or multiple types of the same variable, and put them all together onto one line, as you'll see. So what you have here is a string separated by, or a string and a character separated by a stream operator. So what it's doing is it's taking the string and then putting on the end of this string this character. Now this is the end line character. So if I just go ahead and run this, you can see it prints hello world, and then there's this blank line. That's the new line. That's the return character. If I get rid of that, you can see there's no space there. So it's exactly the same thing as if I were to do this. So it creates that line. This is the new line escape sequence, which you should remember from strings and escape sequences. I can also do this. Produces exactly the same output. You should all be familiar with this, strings and escapes, because it's very important. And I can also do this. I can take hello, separated by a stream operator, put a space in the middle, put another stream operator, and then put in world. Put in another stream operator, and then put endl. So I'm taking the string hello, adding it to the character space, adding it to another string world, and then adding the end line character at the end. And when you put it all together, it looks like that. Now, cout is not just used for strings, you can also use it for variables, as we've seen. So I can create the integer a, and I can give it a value 10. If I clean this out, the value of a is, and then I put the stream operator to separate the string from the new data type a, and then endl. So when I run this, you can see the value of a is, which is this string we created, stream operator a, so it prints out the value of a, not the letter a, and then the endl, the new line. So this is a good way to debug things if you're not using the step-by-step debugger. You can see what the output is by putting these couts in at any time. That's sort of the not-so-good way, sort of the old way before you had a line-by-line debugger to test things, was to get output. So this is, or you can use this to print out variables for other things, as you'll see when we do the sum it all together guessing game program. So this works with any data type. I can change this to a float. I can make this pi. And it adjusts the output to be the right kind of data. I can even make this another string. Car A. Remember, this is one way to initialize a string. Put that in curly brackets. So I can do that with a string. And that's how output works. So it's able to take many different data types and put them all together into one output. Very nice and very easily. Now, when it comes to using cout, it's often best to, whenever you create one line of output, to put all of your stream operators onto one line so that it's nice and easy. You don't want to put more onto it, and you don't want to try to squeeze, or you don't want to try and put every stream operator into its own separate line of code. I could separate this out into 3 lines. I could turn it into this. And I can run it. It's very complicated, produces the same output, but it doesn't look quite as neat and tidy. So, when you're creating one line of output, it should be one line of code. Now, the way I create this string is one way to do it. If you remember when we talked about including files and helper files and making your own .h files, you remember I mentioned the other libraries which are included within C standard lib. One of them is used to create a string data type, and you do that by including C string. So what I can do is I can replace this with a data type called string. And I can say string A equals hello world. And this is actually a lot easier of a data type to work with. It's a lot friendlier of a data type, and a lot of other programming languages have a data type called string, which you can actively append things to or remove things from like you would a normal array, but it's dynamic, which is something we'll talk about a little later. Dynamic meaning basically I can add more to it as you go, and I don't have to start out with a predefined array size as I had to do in the previous example. And this works, no, I didn't put a semicolon. There we go. And this works exactly the same as the last one did. So this is a lot easier of a data type to use, and we're going to be using it in this video a lot more. So that's how you do outputs. I'm going to change this back to an integer. Let's talk about reading from the user. And the way you do that, instead of using cout, is you use cin. This time the arrow points in the other direction because you're reading in from the stream, and that's going to point to the variable you read things into. So when I run this, the program actually doesn't go any farther. It's waiting for input from the user. So what I can do is I can put in a value, hit return, and then the program continues. And you can see that it's stored the value I've inputted into the variable A. And whatever data type this is what the data input gets cast to. So if I run this again, and I put in 25.4, you can see that because A is an int, it gets cast to an int. So if I wanted to make this a floating point, I have to change this to a floating point. Run this again. 25.4. And now the output changes. So whatever you want to read in, you have to... It's a combination of what you look for is what you get. So when I'm looking for a floating point, I'm going to get a floating point. And if I'm looking for an integer, or I ask for an integer, I'm going to get an integer. No matter what I put in, that's what I'm going to get out, because that's what I'm looking for. Now, when you want to do this with strings, it's a little more complicated. So let's change this back to that string data type, and I'm just going to give it a null initialization. Now, you can't say cin. Well, you can say cin, but if I run this and I put in hello world, I only get hello. Now, this is sort of a issue with C++. It's not an issue, it's just a quirk. It's how certain things work. It's because of not issues. I keep saying issues. It's because of the way the stream works. So you can't just say cin. What you have to say is get line. And get line requires the stream you're reading from, so that's cin. and then the variable you're reading into, which is A. So now when I run this, and I put in hello world, you can see I get the entire string, not just up till the space. Now you can format things by using the combination of cout and cin. So I can say cout, enter a string, and L, and run this. So now it says enter a string. So this is how you can format things to ask for specific data from the user. So you can say cout, cin, and then cout. And this is how we're going to write our guessing game program. Now, there's one more thing we should go over, and that's how to do string comparisons. So you'd think normally to do a string comparison. So I'll create another string B. So enter a string, and that's going to read into A. And then I'm going to say enter another string. And I'm actually going to change this so that it matches. I'm getting rid of the end line so that it's you'll see how it's formatted in a second. And I say get line CNB, and I compile that. See how it's on the same line, so it looks a little nicer. So enter a string hello, and then enter another string world. There we go. So that does what we want. Now I'm going to get rid of this. In order to compare two strings, you have to use a function called, or at least in C++, string compare. So we're going to compare two strings, so we're going to compare string A and string B. Really? Really? Huh. Now, to compare two strings, it depends on the data type you're using. If you're using the string data type, which you should because it's a lot friendlier of a data type to use, you can just say if A equals B. I can say cout A and B are the same. Else, cout A and B are not the same. And L. So when I run this, I can put in hello and world, and it says that A and B are not the same. If I put in hello and hello, you can see that they are the same. Now, thing to notice about this is if I put in hello and hello, it says A and B are not the same. That's because when you're doing a string comparison like this, case matters. Now, there are ways to go about this. This isn't the good way to do it with string data types. Remember when you created your own class, you could create functions within the class, and that they could be referenced by the data types themselves. So I can say A dot compare, and then I can compare that to B. And I have to say equals 0. Now what compare does, or dot compare does, is it compares them in terms of alphabetic order. And it will give you one of three outputs. If it's -1, it means that A comes before B. If it's 0, A and B are the same. And if it's 1, A comes after B. Now, the order comes from the ASCII chart. Remember that? So it's not just comparing the alphabetic order, it's also comparing the ASCII number. So it's going to go letter by letter within the strings and compare the values of their ASCII characters. And then it's going to return a result based on that. So if I run this, it should behave in exactly the same way. So if I put in hello and hello, you can see that A and B are not the same. Now in C++, there is no easy way to compare them without case, since these are both string data types. If these were character pointers, there's a slightly different way you can do it. But since this is an introductory lesson, not going to go over that. It's just you're going to have to make sure that the user puts in the data in all uppercase or all lowercase. But you can check for all uppercase or all lowercase, as we're going to do in our little guessing game. So for the moment, I'm going to just comment all this out. So that we can write our guessing game. Now, our guessing game is going to work like so. I'm going to create an int called guess number, and I'm going to give it a value between 0 and 100. I'm going to give it the value 56. Now, the way this is going to work is it's going to request input from the user, and it's going to try, and you're going to try and guess this number. Now, for the sake of simplicity in this video, although I will be asking at the end of this video as the exercise to try and make this so that it reads in, or it makes this a random number, which you should be able to do. It's just try Googling C++ random number. So just for the sake of this video, I'm going to give the program a number already. And then I'm going to create another variable called int user guess. I'm just going to call that 0. Now, I'm going to do this. While user guess does not equal guess number, I'm going to say cout guess a number. And then that's going to then I'm going to ask for a number in. So I'm going to say cin user guess. Then I'm going to say if user guess is greater than guess number. I'm going to say cout too high and line. Else, if user guess is less than guess number, I'm going to say cout too low and no. Now, if the user gets the number correct, if they guess the right number, it's not going to go through this or this. It's going to start the loop over again, and it's going to know that user guess does in fact equal guess number. It's going to break out of this. And then it's going to say cout correct, exclamation point, and oh, I put that in the wrong direction. There we are. So now when I run this, I can say guess a number. So I'm going to put in 50, and it says too low. Okay, so I'll try 75, too high, 60, too high, 55, too low, 57, too high, 56. Correct. Got it right. So that's how this little guessing game works. So it's combining a while loop and a couple conditional statements and inputs and outputs. Now, as another part of the exercise, I want you to take this a step further, and I want you to make this not only random, but I want you to make it repeatable. I want a question at the end that says, do you want to play again? Yes or no? Or Y or N, and then if they say yes, it will start the program over again. So that's your two exercises for the end of this. As usual, I will be explaining those or in the next video. But until then, I will see you all next time.